Hi, this is the second part of the video talking about units, prefixes and engineering notation in connection with mechanical principles, which is a level 3 unit on the subsidiary diploma in engineering. Okay, we're going to look at the table of prefixes first of all. You can see here that we have got some symbols which are letters and the name of the prefix down this column, and the multiplier, which is the number of zeros that it represents, and then the exponent form. Now, some of these we don't tend to use in engineering because they're not in multiples of 3. Okay, you can see here 3, 6, 9, 12 and so on. So hecto does not tend to be used. Deca, deci, even centi, although you can talk about centimeters, but we usually talk about millimeters and meters. So those 4 we can get rid of. Okay, and that one as well. The main ones that we will be using in mechanical principles are kilo, mega, and giga, and milli, and micro. Okay, these ones are very small and tend to be used more in electrical engineering when talking about things like capacitances and charge and stuff like that there. And these ones are extremely big and tend to be used for things like memory and processing power. Okay, now a good example of this is memory in storage for computers. So here we have a floppy disk, which you probably have seen before, and this was quite big. It would fit in your hand, and it had 1.44 megabytes. Okay, then we move to a micro SD card, and this has got 32 gigabytes. Okay, so you can see here, there's the megabyte, the mega, there's the giga, and we're going to have a tera now. Okay, so then you go to another extreme where we have an 8 terabyte hard drive. Okay, so the byte is the unit. Okay, and in front of that we can put M for mega, G for giga, or T for tera. Okay, and that just means that this is 1.44 million bytes. This is 32 billion gigabytes, and this is 8 million bytes. Okay. Okay, if I talk about engineering notation in a little bit more detail, first thing I want to do is look at scientific notation. Okay, and from your maths that you've done previously, you should be familiar with scientific notation. So we have a million, which is a big number, and instead of writing all the zeros, we can express it as 1 times 10 to the power of 6. Okay, 100,000 we can express as 1 times 10 to the power of 5, and so on down the way until we get to the minus numbers here. So 1/10 is 1 times 10 to the minus 1, and if we had 5 zeros in front of the 1 here, that's 1/millionth, 1 times 10 to the minus 6. Okay, now if we look at a scientific notation of a large number, we've got 1.234 million here, and this is because we moved the decimal point 5 places to the left. Okay, we moved it 5 decimal places to the left, which makes it 100,000 times smaller, that number. So if we want an equal number, we have to multiply it by times 10 to the power of 5. In scientific notation, this indice here can be any number. It could be 1, 2, 3, 4, 5, and so on. So we could have 123.4 times 10 to the 4. Now, in engineering, we tend to use engineering notation because it matches up with all the prefixes that I talked about in the previous slide. So these ones here we would ignore. Okay, because they don't match up with any prefixes. 4, minus 5 as well. So this one would match up with mega. This one would match up with kilo. And this one would match up with milli. And this one would match up with micro. Okay, so now looking at the same number again in engineering notation, we'd want to put this in a multiple of 3. So we can do it with times 10 to the power of 6. Here we move the decimal point 6 places to the left, so 1.234 times 10 to the 6, so that would be mega, or 1.234 mega, and then we would have a unit here. Could be newtons or bytes or whatever. If you take the same number again, we can do it with another multiple of 3, which is to the power of 3, and we're moving the decimal point 3 places to the left. That was 6. So we've got 1234 times 10 to the power of 3, which would be kilo. Okay, so the main thing with scientific notation is try and use multiples of 3 with the indice to make sure that you can write it in shorthand with the prefix in front of the unit. Okay, so if we look at some examples now, here we have a force, 43,645 newtons. So we can write that in engineering notation. So the decimal point is here. So if we want to write it in engineering notation, we have to use a multiple of 3. So moving the decimal point 3 times to the left. So 43.645 times 10. Now you might go, well, what do I put here? Well, what have we done to the number? We've made the number 1,000 times smaller by writing 43.645. So we have to compensate for that and multiply it by 1,000. So we have to make it 1,000 times bigger again with this part here. Okay, and now we can use the prefix. The prefix for times 10 to the 3 is kilo, and that will be newtons. Alright, so we can write 43.645 kilonewtons. Example 2, 0.745 amps. So this time we're going to make the number bigger because we want to put this into milliamps. So moving the decimal point to the right 3 times makes it 745, and we have to multiply it by a number times 10 to the something. So what have we done to the number here? We've made it 1,000 times bigger, so we have to make it 1,000 times smaller so that these two numbers are equal. So we multiply it by times 10 to the minus 3, and that is still amps because we've got this number here. If we want to write it as milliamps, we drop the times 10 to the minus 3 part, and we write 745 milliamps. Example number 3, 300,000 watts. So the decimal point's here. So we're going to make this smaller. Reduce some of the zeros. So move it 1, 2, 3 to the left. We get 300 times 10 to the something. And again, you have to think about what you've done to the number here. So we've made the number 1,000 times smaller. So we have to multiply it by 1,000 again, by times 10 to the 3 to make it the same number. So that is 300 kilowatts. Example number 4. Okay, we've got a really small number here, so we want to express it with 68. So 1, 2, 3, 4, 5, 6. There's the decimal point now. So we've 6 zeros there. So 68 times 10 to the something meters. Now again, we've made the number 1,000,000 times bigger, so we have to multiply it by 1,000,000th so that these two numbers are in fact equal. Now the engineering prefix for 1,000,000th is micro, so we can just write 68 micrometers or micrometers. Okay, example 5. Sometimes we get a number in scientific notation and we want to put a prefix in front of it. So here we have times 10 to the 5, which isn't in a multiple of 3. So a suitable multiple of 3 to change that to would be times 10 to the 6 ohms. Okay, now we've got our 42. So we've made this number 10 times bigger, so we have to move the decimal point to the left one. So it'll be 4.2 times 10 to the 6, or 4.2 mega ohms, as mega is the times 10 to the 6. And finally, example number 6. Again, we want to express this number in engineering notation. So times 10 to the minus 10. Well, the nearest one to that is times 10 to the minus 9 farads. So we've got our 47 here. So at the moment those two numbers aren't the same. We've got 47 times 10 to the minus 10 and 47 times 10 to the minus 9. So by changing this from minus 10 to minus 9, we're making the whole number 10 times bigger. So we have to make this number in front of it 10 times smaller. So the decimal point will go 1 to the left. Okay, so the engineering prefix 4 times 10 to the minus 9 is nano. So that will simply be 4.7 nanofarads. Okay, so that concludes this video discussing engineering notation and prefixes, and hopefully it'll help you with your engineering mechanical principles.